This is section 7.1, part A, parabolas. The I can statements for this section: I can analyze and graph equations of parabolas, and I can write equations of parabolas. So in chapter 7, the entire chapter is about conic sections, or just a conic. These are figures that are formed when a plane intersects a double-naped right cone. So if you look at the pictures on the bottom, these are double-naped. It means it has two different cones, one's going up and one's going down. The different ways you can cut through these two planes will give you different figures. If I cut it slanted, it's going to give me a parabola. If I cut it straight across horizontally, I'll get a circle. If I cut it horizontally at a little bit more of a slant, I'm going to get an ellipse. And if I cut it vertically, I'm going to get hyperbolas. When the plane intersects the vertex on the cone, the figures that are formed are degenerate conics. So a degenerate conic can be a point, a line, or two intersecting lines. So if I cut straight in between where the two cones touch, it's going to give me a point. If I cut it on that diagonal, it'll just give me a straight line. And if I cut it right down through the center, it would give me two intersecting lines. Now the general form of equations for all conic sections are ax squared plus bxy plus cy squared plus dx plus ey plus f is equal to 0, where a, b, and c cannot all be 0. Now some of them can be, but not all can be 0. So we're going to start our conic sections with parabolas. When we're dealing with parabolas, we have a locus. A locus is a set of all points that fulfill a geometric property. So like I said, we're going to start with parabolas. A parabola represents the locus of points in a plane that are equidistant from a fixed point, which is called the focus, and a specific line called the directrix. So any point on that parabola is going to be the same distance from the focus to that point as it is from the directrix to that point. So if I pick this point over here, it's the same distance to my focus as it is my directrix. These values are the same, these values are the same. It's going to be the same for all values that are on the parabola. A parabola is symmetric about the line that's perpendicular to the directrix, and it goes through the focus point, and we call this line that it's symmetric about the axis of symmetry. The vertex is the intersection of the parabola and the axis of symmetry. So this line is our axis of symmetry. The parabola is symmetric about that parabola. If it's going horizontally, it'll be symmetric above and below. If it's going vertically, it'll be symmetric to the left and to the right. The point where your parabola touches that axis of symmetry is your vertex. So when we're dealing with parabolas, there are two standard forms. There's the parabola that opens vertically and the parabola that opens horizontally. Now deciding which way it opens will help us determine which equation it is. If it's opening vertically, our standard form of the equation is x minus h squared is equal to 4p times y minus k. Now when it opens vertically, it can either open up or it can open down. If this p value is greater than 1, which means it's positive, so if p is positive, it's going to open up. If our p value is less than 0, if our p value is negative, it's going to open down. Horizontally, it's going to have the exact same type of concept. If our p value is above 0, or if it's positive, it's going to open to the right. And if our p value is negative, it will open to the left. Now, if it is opening vertically, the vertex is going to be at hk. The focus will be at h and k plus p. Our axis of symmetry will be x is equal to h, and the directrix will be at y is equal to k minus p. If we look at the one that opens horizontally, the vertex is at hk, the focus is at h plus k and h plus p and k, The axis of symmetry is y is equal to k, and the directrix is x is equal to h minus p. So if it's opening vertically, the x part is the one that's squared. If it's opening horizontally, the y part is the one that's squared in your equation. So for the equation, y plus 5 squared is equal to negative 12 times x minus 2. We need to identify the vertex, focus, axis of symmetry, and directrix, and then we're going to graph that parabola. Now right now when we graph parabolas, I just want you to find the general shape. We're not actually going to be finding any other points besides the vertex. We just want to see which direction it's opening. So because this equation has the y part squared, we know the general form is y minus k squared is equal to 4 times p times x minus h. Now when we find our values, when we pull stuff out of parentheses, remember you change your signs. So this is my k, this is my h. When we pull it out of parentheses, we change that sign. So h is going to equal to our k value. When we pull it out and change our sign, it's going to be negative 5. We need to find our p value. This right here is equal to our 4p. So if we divide both sides by 4, we're going to get that our p value is negative 3. And we're going to take those three values and just substitute them in so we can find the values of our vertex, focus, axis of symmetry, and directrix. Our vertex will just be located at our h and our k value. Our focus is at h plus p. 2 plus negative 3 gives me negative 1. And my k value is still negative 5. Your axis of symmetry is going to be at y is equal to k. And our directrix is x is equal to h minus p. And 2 minus negative 3 is a positive 5. So if we plot all that information first, our directrix is that x is equal to 5. So if we go to 5, we're going to go put a dotted line through x is 5. We know our axis of symmetry, where it's symmetric about, is going to be y is equal to negative 5. We know because this is y part is squared, we know it's going to open horizontally. And because the p value is negative, we know it's going to open to the left. We know our vertex is at 2, negative 5. And we know our focus is at negative 1, negative 5. You start at the vertex, you go away from the directrix towards the focus, and make your parabola shape. Again, for right now, I just want you to know what the general shape is. We'll deal with finding exact points later, but right now I just want you to have the general shape, which direction is opening. But you should have your axis of symmetry, your directrix, your focus, and your vertex plotted, and then make this shape. We need to write y equals negative 1/4 x squared plus 3x plus 6 in standard form first. So we need to write it in the form of a parabola. And then we're going to identify the vertex, focus, axis, symmetry, and directrix again. So if we start with that equation, the first thing we need to do is get that x squared part by itself. So I'm going to factor out this negative 1/4 from both parts of the x. So negative 1/4 x squared divided by the negative 1/4 will just leave me with x squared. And 3x divided by negative 1/4 will leave me with negative 12x. Now we want to be able to write this as a whole quantity squared with the x. So we're going to want to be able to factor the x squared minus 12x. Right now there's not a constant with that, so we are going to have to complete the square to be able to get that done. Remember, when you are completing the square, we take our b over 2 value and we square it. and we're going to add the positive and negative value into the parentheses in there. Now the b value is the value that's in the x by itself. So for us, this is going to be negative 12 over 2 squared is equal to negative 6 squared, which is equal to 36. So inside that parentheses, we're going to put a positive and a negative 36, because when you add something in there, it has to be able to cancel back out to 0, so you're not adding anything extra into the equation. Now we actually only need the positive 36 in there to be able to complete the square, so we want to take that negative 36 outside of the parentheses. To do that, we're going to have to distribute the negative 1/4 to the negative 36. When I distribute that, negative 1/4 times negative 36 is a positive 9. Now because we do have a perfect squared trinomial inside, we can go ahead and write that. 9 plus 6 gives us 15. When you are completing the square, whatever part ends up in our square here is what's going to end up down after we finish completing the square for our perfect square trinomial. So this is, because this is a negative 6 squared, inside of that will be x minus 6 squared. Now we still need to finish getting this into standard form, so I'm going to take that 15 to the other side. Right now it's positive, so we are going to subtract it. And when we subtract that 15 to the other side, we're going to end up with y minus 15 is equal to negative 1/4 times x minus 6 squared. Now we need to get that x minus 6 squared part by itself so that it's in the correct form for a parabola. To do this, we need to get rid of that negative 1/4. Right now, this is basically dividing by a negative 4. So the opposite of that is we're going to multiply everything by a negative 4. So we have negative 4 times y minus 15 is equal to x minus 6 squared. So if we rearrange this, if we multiply by that negative 4, we are going to have negative 4 times y minus 15 is equal to x minus 6 squared. Or if we switch the order so that it's in the form that we're used to seeing, this is going to be x minus 6 squared is equal to negative 4 times y minus 15. Now this is in the form of a parabola that's going to open vertically because the x part is squared. And the standard form of that equation is x minus h squared is equal to 4p times y minus k. So in this case, remember when you pull it out of the parentheses, you change our signs. So our h value is 6, our k value is a positive 15, and our p value, because 4p is equal to negative 4, we know that p has to equal negative 1. So now we need to find our vertex, our focus, our axis of symmetry, and our directrix. So our vertex will just be at 6 and 15. Our focus will be at 6 and 14 because 15 plus negative 1 is 14. Our axis of symmetry will be x is equal to 6. And our directrix will be y is equal to 16 because 15 minus negative 1 is 16. Now we need to graph this, and we're going to have to change the scale on this graph a little bit before we get started. So the first thing we need to do is graph our axis of symmetry. Our axis of symmetry is going to go through x is 6, so we know our graph is going to be symmetric about that line. It's opening vertically. Our p-value is negative, so we do know it's going to open down. Our directrix is at y is equal to 16. Our vertex is at 6 and 15. Our focus is at 6 and 14. We know it's going to go away from the directrix towards the focus, and it's going to open vertically, and it's going to open down.